Microbes are everywhere. They present in the air, they present on our surfaces, and they also an very important component of our bodies, both inside and outside.
Did you know that the biggest bacteria is as big as our earlash? Its size can reach up to 2 centimeters long.
My research explores how disinfectants alter indoor microbiome communities. Chemicals kill the majority of bacteria, but leaving antibiotic-resistant genes behind. Understanding those effects can help us to design chemicals more targeted on pathogens without fostering superbugs.
Okay, hi Yixing. So what motivated you to put effort and time in this field?
I'm very interested in
While
biology.
collecting samples in
to
ICU
have a different-
and watch patients die from infection antibiotics couldn't cure. To the medical team, it was routine, but for me, it is hard. Now I have to ask, are our disinfectants part of the problem, making these pathogens stronger? I think the major challenge is the low biomass of our samples. So to overcome this difficulty, we adopt a neutral sensitive preparation kit and with the PCR amplification to rescue the rare DNA fragments. And then we sequence at a very deep depths through all these steps so we can recover the rare microbiome signals hidden in the noise. Microbes are outpacing us. Every chemical attack lets the toughest survive and share resistance, often with deadly strains. My mission: crack their code before they face the next crisis.
Not all the microbes are bad. Let the harmless ones stick around. They can make your families healthier long term. Cleaning smarter, not harder.